But Marshmallow, I don't get what the alpha photon beta particle is here for gamma or alpha radiation. Well, you don't really have it like Salty or some scientist, right? You know, it's like you just emit alpha radiation, but you'll have neutrals and protons, and this could be businesses, right? In particle physics, it's different. That's X and Y, and that's the time of my battery, and or the time it is plus the battery, and that'll drive this is at 45. And I know it's actually the other one, right? Because as my battery draws down, it's this way, but that's okay because they're inverted. It's this thing. We know that we want it up and right because that's what this describes in this form. But when we do the other models off of this snowflake, they can still be the same L brackets, photon, gluon, W boson, Z boson. It will just do that. But in life, you know, you're going to have protons and neutrons, zeros and bosses over at one of the big banks or something like that while I'm adding out this system. Let's see if we can get this out because we need those L brackets. We need those firing pins and everything else inside of this thing because that deals with our trajectory. We are actually aiming for this. This is what that element is supposed to do. There are other elements on the table. There are other businesses and other systems when we want this semi-imperial mass equation. Um, let's see if I can get some context up here. Okay, so this is logarithms and me charting it out. When you look at the Gaussian, when we get into this here in a second, about what's going down there, that's basically what we'll be talking about here.
At all, what is causing this? And if we are speculating that there is a nuclear force, and we are, so we'll say here is the nucleus, and there's some kind of force that's holding it together, there must be, because there are protons and there are neutrons in this nucleus,
All right.
and protons are
So
positive.
let me just stop you right there because this is stuff that is beyond A-level physics. This is, I mean, it is A-level physics. It's Sheldon dealing with, I don't know, I forget which name of it is on that one question he couldn't answer for the dean there, the young Sheldon. But we're taking this to a battery right here, like, right? Because that's what Gaussian essentially is. I don't know the ID and I don't know the OD. I don't know how much magnesium, lithium, copper is inside of there, so therefore my yield is not going to be good to that battery life or any of the elements in there. And as they decay, there is positive and neutral parts of it. It's on, it emits light. That's good in terms of neutrally shifted. It's right at the moment clear. It's not necessarily held in hand to the moment as far as that rechargeable battery in the phone, but that's its passive effect. Now you could blue shift that by utilizing it correctly from I drew it out here. I said something out about it. Note that I just wanted you to start. I had 66% on my battery, and that is the X function here. And we're saying that it's gonna creep out in time. As this comes down, this actually drops down semi-imperial. And the more I use it, let's say we actually break that down into cleaner logarithms for this system that each have that zenith in it, that I used it, I did something with it, that I would have an effect. You know, you charge a battery, does it have more weight? Well, if photons don't have mass, but semi-imperial equation tells me that the phone got hot. Actually, heat makes it lighter. It's a weird thing like that. Cold is something that's more dense, so most liquids in the atmosphere that we have right now condense when they get cold. They change states, and it's a smooth transition between these L brackets and N or P. Easy to prove this part. How does it affect into the next part is another P or an N or an irrational number that we know it could fall straight down or with momentum or decay, explicitly decay, but here we're changing it over to we want it to decay. See, very easy problems and hard problems. You know, we want it to decay, but so we have to define it as superposition in a positive form. That is harvesting the corn. You got to do it. It's negatively growing in that garden now, but the new energy by that value is moving in that direction linearly or laminearly in that field. Okay, so when you're trying to determine a million COVID patients like 3B1 here was doing, we're basically taking the biographs of hospitals and patients, right? And we're saying that there are certain regions where these numbers are coming together while we're adding in the plots, graphing those plots, and changing the form so that way we're not just graphing it. Now we're giving ourselves some space to determine when that rough bracket is supposed to hit that window, because that's the semi-imperial mass equation. That is that we figured out all the general field points so that the observation of this thing arcing like that it was semi-imperial. You got ups and downs inside of here. It's not just one motion. There are multiple motions, well, up and down here, but there are strange motions to it as well, that it was up, but it wasn't as up as it could be, or it was down, and or comparatively, and the states of that matter as they come into hydrogen to 118 on the periodic table. You could argue Feynman's one electron, right? But that doesn't mean that in this system, that's what that represents. So another good one here is the apple in the vacuum, right? It's never going to be an apple again. Heat death, decay is going to eventually proteum to where we are in hydrogen and other things, or where you are in that mission to say, I started the day hydrogen, I ended it fallovium, right? And then I'm going to take that pack, and that goes to the scale house based on its photon and its gluon factors. This is the way we observe this. The photon actually, even though it's this little picture, is still a timeline of an action that takes to conduct that experiment. And over those things, you'll start to pick up on this bandwidth of the area of the black body problem to start to deal with this Maxwell, Rayleigh, or Jeans effect when I'm going for not too hot. There's not, as much as I can have a person do 1,000,000 push-ups in the stone mill, this is not going to do me any good. I need you to do these, and there's kind of a time limit to it. So if you're pegging like that, and this place isn't housed to handle that at the moment, then you'll get a Fuzzles effect in the wiring there, or some, wherever the connection points are there for the essentials of calculus and that diamond necklace. And it's a ladder problem here. The rungs on the ladder work this way too. We did the reaction, but did you get Tylenol to aspirin out of that reduction inside of here as far as the orders in which you're doing that? Now again, once you hit that phase limit, or certain noble gases, ideal gases, noble metals, so on and so forth, that you can start to see that not only periodic table is broken down that way, but it's also broken down in the structure of the periodic table, the FPs, D orders, and so on. And so when we look at this, we get that problem of over-homogenization in terms of race neutrality. It's not hydrogen, and it's not fallovium. It's not air out there. It's 70% nitrogen and oxygen, and that might be different at the top of the Himalayas and definitely at the bottom of the ocean. There's a hydrogen and oxygen in there, but get to that saline at the bottom of it. There's other elements which cause an IH differential as far as that. And again, there are certain ecosystems where the biodiversity is going to cause a problem in that effect. That, there are other animals in there. At a most, rabbit and the turtle here about somebody put you in a jar, but Earth, you're just born in, so there's that. But again, cattle, bull, pig, if we got to tigers out in some place, hey, if it come to hunting it and we can do that, then that's what it is. But again, if this goes beyond that, and there wasn't a semi-imperial equation for you to put it to the origin source, or that orchard paradox there, then like hunting all the bunny out or selling all your Apple phones. I'm not saying that's 100%, but you can look at that and say, I don't have any criteria, I don't have any students. Overtrain them Corinthians, right? The bull cutters technique, when you're not ready for that, your AI is not ready, right? And you just telling all your friends this is how you shear the sheep and do things like that, and what do? You lose your business. Do you need to do that? Definitely. There are states of matter where that's necessary, and on the other side, right out of the mouth of babes, right? Just couldn't stop 42 from saying it with a kid kind of stuff. inside here, this guy's got to be the dominant. Even if you have the gun, brother, they'll kill us all. I don't want to lie to you, but honestly, it doesn't matter. They're going to do that to them when he beats the shit out of them, but doesn't actually just crush his head in. Use the smarts, use your strong, play it out, fucking works. But obviously that's Scar's kid there, Mufasa. But back to being a soldier or something like that. It's tough play. Just stuff to think about here today. Real close between sniper and seeker and enemy. In the glass, you're watching them dig a hole. Well, you had to dig a hole to do what you need to do, and when we're trying to figure out these origin sources and everything that comes with it, it's gonna get real. So that's my note. Catch you on the next one.